Okay, I think we've started. Okay, so hi Regan and Wekesa and Nelson. Sorry, forgot to say hi to Nelson. How are you guys doing?
I'm fine.
Okay, sasa
I'm
Wekesa.
good. Kopoa.
Sawa. Sawa.
I'm also
Hey,
good.
Regan, I have not seen you in a while. Ama ni mimi ndio
Oh, I
sipendi.
ran into some phone and laptop problems.
Mm-hmm.
So recently ndo fix my stuff.
Mm.
Yeah. But I'm
Okay.
back now.
Sawa. Sawa, karibu. We did year 6 last week. Actually last week the presenting was mostly done by the guys. Mambo had a presentation. Who else? Evans was supposed to do a presentation for 3JS. Think, are you still in a position to do that, Evans?
Today I'm at another time.
I think we can do it tomorrow because see, it's not a lot, Indio.
Yeah, I can try do it in 30 minutes.
So then we'll. I think even if we have time today, then you can try to. But I think it's better.
Yeah, because I saw you had already come up with a timeline or an outline of what you're supposed to do this week. So
Yeah.
if it will tamper with that, maybe you can do it.
Yeah. Yeah. Let's see today's lesson. Tuone kama we'll find time.
So.
Yeah. Did you join? Who joined Friday's session? When we talked about Vue, and I'm very curious to hear your thoughts on like the two frameworks. We did Vue and React. What did you guys think of the two?
Personally, I think I'll remain in React. Vue is not that bad. It has several things that are easier to do than React, but the fact that I'm already into React, I'll stick there.
Yeah, but you see why people say it's easier to get started with.
Yeah, I saw. Yeah, there's that reason. Yeah.
Mambo, did you join us for that session?
Yeah, I was in. I dropped out of the React part katikati, but I was in through the Vue part, all of it.
Yeah. You didn't run away as when you saw React code.
Actually, I'm more comfortable with React than with Vue at this moment.
Yeah.
Yeah. So.
But you can see like how quickly it gets complicated very fast.
Yeah, that's one thing about React. Now, looking at Vue, it kind of got me interested. I've never actually done anything with Vue before. I've heard about it, but not really. But now my interest has been piqued.
Okay. Yeah, but it's React is an interesting framework. I think mostly because of it makes you feel very smart. I think I mentioned this in that session. Because how you see, it makes you feel very intelligent. There was a podcast I listened to a few months back, and they had a debate, and they were asking whether React is only good at being popular and nothing else. It was a very interesting talk. But now comparing them on Friday, you could clearly see how for a new beginner, React can look very, very intimidating. But once you get a groove of it, it's very enjoyable. Okay. Also here, Nelson, you are also here for that session.
Yeah, I was there. And my comparison of the two, first of all, I can say that I saw some similarities.
Yeah.
Yeah, of the two. So actually, I've never written some code in Vue.js, but that little introduction gave me a lot of interest in it. So it's one of the things in my bucket list to maybe to do in the next coming weeks.
Yeah.
I'll try it again. I'll try it on
Okay. It's very uzuri yake ni it's very, they do a lot of things for you.
Okay.
As in, you don't need to they're both okay, zote ziko sawa, but there is a learning curve to React.
Okay.
Okay. Hi Eunice, how are you?
Hey, I'm good.
Okay. All right, so let's start. The others will join us baadaye. They'll find us, utapata kama tushaanza. Okay, so today's topic is, so this week we'll be walking through some, so the next 3 days we'll do like JavaScript under the hood. So what that means is we will look at things like the call stack. JS has a call stack. We'll also look at the event loop, which gives JavaScript the illusion of being an asynchronous language. So more than like single thread, it behaves like it's doing two things at the same time, but it's actually not. What else? What else? We covered the execution context very briefly last week when we were talking about let, var, const, hoisting. We looked at it briefly, so we'll cover more of it today and see exactly what it's actually doing, because some of those things are very confusing. So we'll start with the call stack, and then we'll move into the execution context. You can see my screen properly. It's visible.
Yes.
Okay.
Yes.
All right, so we just have an empty document. Hakuna kitu hapa. And then I just have my script. And then I just have some function calls here. I open my console, my DevTools. There's nothing here. I can simply console log some value here. Loaded. So we have the script loaded, so it's working properly. So now let's remove it. All right, so does anybody have experience with, have you ever heard of something called the call stack? Anybody? Has anyone heard of that term before? It doesn't even have to be related to programming, not particularly JavaScript. Has anyone heard of that term before? The call stack. Okay. All right, so let's go through it. I have some notes here that I took. So what you need to remember about JavaScript is it runs on a single thread. Now that can sometimes sound very confusing, or you're like, what do you mean by a thread? So we have single-threaded languages and we have multi-threaded languages. So multi-threaded languages can access more than one thread on your machine. The way to think of, like, just think about it like an actual thread. Your computer's CPU has multiple threads going out of it. So depending on, so for example, if my application wants to do 10 things at the same time, right, and you're using a multi-threaded language, it can pick one thread for each process. So for each thing you want to do, it can pick one thread. But with JS, we don't have that capability. We can only just use one process. So think about it like a pipe that consumes all your JavaScript code. Okay, that's your main call stack. It doesn't go past that. Anytime it needs to do some asynchronous behavior, some multi-threaded behavior, it doesn't have that capability. It can't use the multi-threading that comes with your CPU because it's a single-threaded language. So single sequential flow of control. So everything is controlled through one pipe. So if you close off that pipe, it blocks your entire application. A perfect example of a function in JavaScript that blocks the stack is the alert function. So anytime you use the alert function that comes with your language, you cannot do anything else on your page. It hangs until you give it a response. It's already isha hang already. It's not allowing me to do anything else. Okay, let's say okay, and then let's refresh the page again. So we have hi there, but you can see right here, it's just loading forever because we are not allowing the application to close because the alert is blocking the main pipe. It's a synchronous operation and it will keep running and keep running the whole kila kitu imekwama. You can't do anything until you say, okay, the UI will be blocked. You can't do anything. So now you can do something, Sasa. So this is a perfect example of something that will block that main thread. So if you had something huku chini, you can see the hi there has not come. Haiko hapa. It's because the alert is blocking it. Until this operation is done, we cannot see anything hapa chini. This will not be executed until the hi there has finished with that main pipe. So that is what we mean when we say that JavaScript is a single-threaded language. We do have examples of multi-threaded languages like Python. I think PHP, C, and C++ are also multi-threaded. They have access to multiple threads. So that behavior would not happen. It would simply give that functionality for console logging hi to a different thread. And then that would execute that and then bring back the response. But because JS is single-threaded, you don't have that capability. Right, so now we have something called a call stack in JavaScript. So a call stack, but it's not unique to JS. It's there in almost, I think, all programming languages. So a call stack keeps track of your functions and manages something called the execution context. So think about the call stack like a container. Think about it like a container. And I do have something that we can use to visualize that. So I will just call stack visualizer. I think this is the one. And I will send you guys the link to this page. Okay, so this is exactly what I want you to think about ukifikiria call stack, this thing here. Just a container, right? And then the way it works is anytime you have a function, your function is put on the call stack. Inakangwa hapa. So if I come and I change this code, I don't want hii yote hapa. I can have my own example. Let's simply say function, say hello. Then nifanye nini sasa? Okay, then we have return, say hello, and then I'll simply execute that function. So now, before we even have the say hello on the call stack, we already have another one. So JS, the actual language, right? We have something that is called the global execution context. So the global execution context is anything that is within your global space, your global scope is going to be executed first. So hoisting has something to do with this. So even before you have something here, right, the actual JS that you've put in your program is going to be run. So that's why you have the this keyword. The this keyword is initialized by the global execution context, the window object, but we'll look at those things later. But for now, just know there's some invisible function that is below this call stack. You can't see it, but I'll show it to you in the browser. So now we want to see how this is executed. So we've said that a call stack keeps track of your functions and manages the execution context. So at the bottom of our call stack is the global execution context that runs all our JavaScript code. Okay, so when a script calls a function, the interpreter adds it to the call stack. any functions that are called by that function are added further up and run where their calls are reached. What I simply mean is, if you had another function hapa ndani, within this say hello function, it's going to be put on top of the say hello in the call stack. The call stack has something that is called a last in, first out approach. So the last thing that came in will be the first thing to go out. So enough talking. Now let me show you using this visualization what we mean. So now if I execute, if I run this function, so let's run it. Okay, so let's step through the program. So the call stack is currently empty. There's nothing here. It's already evaluated the script. So this means our global execution context is already done. Don't look at these two for now. We'll talk about this when we get to the event loop. So now if I start to step through the program, there we go. You can see say hello is now on the call stack. Then it's going to get executed. And then once it's done, it will get removed from the call stack, shatolewa. So that's what the call stack does. It keeps track of your function calls. So now, if I was to come here and say, I want to come here and have another, function, and then simply return But now I don't want to call this say hello again in the global scope. I want to call it up and near this function. So that we see what we mean when we say that if you have another function called within another function. So for example, you want to call say hello again within say hello. This say hello again will be put on top of the say hello in the call stack. So let's do that. Let's come here and now say hello again. Then let's call that function. Let's try. So let's run the code. Okay. Now let's step through the first one. So based off of what we have, the first thing that will happen is this will get executed. So say hello will be put on the call stack. So let's do that. There we have say hello. Within say hello, we are now calling again say hello, this other function here. So now this will be put on top of say hello. There we go. And then for as long as say hello again has not finished executing, this other say hello will remain on the call stack and will only be popped off after say hello again has finished executing. So now once we execute say hello again, it's going to get removed off the call stack. And then now we can finish executing the say hello. And then that also gets popped off the call stack. Now, if we try to see that now, we've seen the visualization of it. So let's have another one again. So now, another one, function nested 2. And then simply, we don't even need to return anything, but I'll just do it for clarity. Just return an empty string. Now, I want nested 2 to be called within say hello again, not within say hello, so that we see that the way they stack on top of each other, hence the name a call stack. So now if I come here and I instead call nested 2 right here, so what is the order of execution, right? So in the global scope, the first thing that gets executed is say hello. So say hello is put on the call stack. And then within say hello, we execute say hello again. So say hello is also put on the call stack above say hello. and then say hello again calls nested2. So nested2 is put on top of say hello again. So now we have 3 functions on the call stack. And the reason we are not popping off say hello is because say hello is still running, because say hello again is inside of say hello. So let's try now. Let's execute it. Say hello. Okay, so that's the first one, this thing. And then within that function, someone has a question. Or someone has a comment. Let's see. Okay, I zoom in. Okay. Better? Maybe that's better. So now we have say hello in the call stack, right? Let's step through it again. We now have say hello again in the call stack because it's being called instead of say hello. And then now again, within say hello again, we are calling another function, nested2. So now say hello again will not be popped off because it has not finished executing, because nested2 is being called inside of say hello again. That's why it's not being popped off. So for as long as say hello again is on the call stack, then it means even this one will never be removed. So the only way to remove say hello is to first of all remove nested2. Then that will in turn now move say hello again, which will now give this one the opportunity to also be removed from the call stack. So now let's go through that process. Nested2 goes off the call stack because we finished executing. Say hello again is popped off the call stack as well. And then the last one is say hello is also popped off the call stack. So that's what we mean by the call stack. And I think you can see what we mean by last in, first out, because the last function, right, the one that is at the top, meaning that the one that was put into the call stack last, should always be the first one to be removed. Let's go through that example again. So if I run the function one more time, let's run it again. Okay, now let's go through it. Step through it the first time, say hello. This is the first one that has come in at this point. Say hello again. So this is now the last one into the call stack as of this point. And then this is now the last one at this point, the last function. We said it's a last in, first out data structure. So now the first thing that is going to go out is which one? It's the nested one. Hence the last in, first out. It's the last thing that came in, but it's also the first thing that comes out of the call stack. And then they say hello again, and then they say hello. Is it sinking in? Is it making sense by what we mean by the call stack? Anybody with a question? Anybody? Is there anything I need to explain again? Okay. So for now, don't worry about the micro task and the task queue. We'll talk about these ones when we get to the event loop. Okay, so now let's do another example from them. So the call stack. All right, so now what we have here is we simply have a bunch of functions. So if we start with the first function, right, the first function is simply calling the second function. That's what it's doing. I was to just edit this. I don't think I have access to like something make you visible what's going on. I don't have access to like a linker here, so I have to do it manually. I hope you guys can see like it's just a bunch of functions are calling each other. That's the only thing that's going on here. As I do this, does anybody have a question, a comment, something to add? Nelson, you told me you work with Ruby, right? Is Ruby multi-threaded? How do you handle asynchronous operations in Ruby?
Yeah, I think it is multi-threaded.
Okay. All right, so I am done. So we simply have a bunch of functions calling other functions. So the first function that we call here, the first function, calls second, then second calls third, then third calls fourth, then fourth calls fifth, then fifth calls sixth, then sixth calls seventh, then seventh calls eighth, then eighth calls ninth, and then that's it. Ninth calls 10th, and then that's it. 10 is not calling anybody. So now, based off of what we have already talked about, who can tell me what is going to be the first function that will be popped off the stack? Because those are the terms. You push a function into the call stack and you pop it off once you're done with it. So based off of what we've done, what is going to be the first function that is going to be popped off the call stack with what we currently have? Anyone just try to see whether you can figure it out. What function will be popped off the call stack first?
The 10th.
Are you asking which one will be popped off first?
Yes, first. Which one will be popped off first?
Probably
The 10th.
Which one?
the 9th.
Okay, so Mambo says 9th.
The
Who else?
10th.
10th. So 9th, 10th. Who else says 10th? Okay, so let's try. So we want to see what function will be popped off the call stack first before any other function. So let's run the code. Okay, let's start to evaluate them. So we've put first on the call stack. Then first put second on the call stack because first is calling second. Then second calls third. So third is put on the call stack. Then third calls fourth. Then fourth calls fifth. Then fifth calls sixth. Then sixth calls seventh, eighth, ninth, 10th. 10th is not calling anyone, right? So now, because we are done with execution, because 10th is not going to call anybody else, so 10th gets popped off as the first one because it's the one that's not calling anybody else. It's finished. And then we remove 9th, and then 8th, and then 7th, and then 6th, 5th, 4th, 3rd, 2nd, 1st. Is it making sense? Are you guys able to follow what is going on? So this is also adhering to the last in, first out, because the last thing that comes in is the first one that goes out. Because the 10th was the last thing to come into the call stack, and it was also the first thing to go out. Any questions? Is there anything I should repeat? Okay. All right. So now, with that in mind,
I have a question.
Mm-hmm.
Yeah, I was just wondering, how does the call stack handles a function that recursively calls itself, a function that doesn't have any exit points?
Yeah, that's a very good question. I was just about to ask that. So you mean, how does it handle a function that calls itself?
Yes.
Okay, that's a brilliant question. So now, if you guys, there's a very popular website that is used by developers. The name of that website is basically referring to what happens when you do exactly what Mary just talked about. So that website I'm talking about is used by a lot of developers, Kuiba code. So does anybody know what I'm talking about? It's a very popular website.
Stack Overflow.
Stack Overflow. So what happens is the call stack has a limit. You can't keep calling it forever. It has a limit. So whatever Mary is talking about, the recursive calls. So if a call calls itself forever, for all eternity, it's going to blow the stack. That's the terminology. So let's do an example, because I don't think I can do it here. I think it will actually make the whole page crash. So let's do it in our browser. So let's go into this. All right, so let's go into the JavaScript. Now, for KU, and then we have those. Okay, let me just remove this alert here. No, even after I've saved the document, I still can't. I have to say okay for it to actually even show the changes. Okay, so now we see this in the console, and they are the way we want them, because we now have, also remove this, are calling caller 1, then caller 2, then caller 3, right? Now let's go into our dev tools. Let's go into sources, and then let's go into app.js. And then I want to put a breakpoint right here. Now you can see that we have a call stack here. It's empty because there's nothing we are doing. We have the call stack right here. So we want to mimic this behavior of this is called, popped off, this is called, popped off, because for this example, we are calling them separately. Hakuna mwenye, there's nobody who is calling based off of another function. They're all in the global. So when we call the first one, it's going to get executed, popped off, and then caller 2 is going to be put on this call stack, popped off, and then call 3. So if we now run that function, okay. So now currently we are here. We have put a breakpoint here. Okay, now if we go into, this is the global. So we already have this set to window. Let's look at scope. This one doesn't have anything right now, but you can see in the call stack, we have an anonymous function. This is what we talked about when you talked about the global execution context. It's this anonymous thing that you see here. That's why I told you, visualize in the example I showed you, that chini all the calls, there's an invisible call up. It's this anonymous one here. And then let's step through the code. Okay, we want to see the first thing that's going to be put on the call stack. So you see caller 1. Chini caller 1, we have the anonymous. So caller 1 is being called. Okay, it's being executed right now. But when I executed, it still hasn't finished executing. Then when it's done, we go to caller 2. Caller 2 is now put on the call stack, executes, inatolewa kwa call stack, then now caller 3 is executed. Inatolewa kwa call stack. That is what happens. So we've been able to see it visually and actually see it kwa code yetu kwa the browser. Now, let's do a recursive call. What we mean by a recursive call is one of these functions, we want one of these functions to call itself forever. That's basically what we're saying. We don't want a base case. We don't want it to get to a point where it says, okay, now you should stop calling yourself. That's what recursiveness means. So if I simply remove these two here, right? Because from the definition, we want to have a function that will call itself. So we want caller 1 to call itself. So let me open the terminal. Let me go into the console. We simply have I go first. Then I come here. And then I'll simply move this to this side. Now I want caller 1 to call itself. So I'll say caller 1 and then call yourself. What happened? That I removed this thing. Go into the console. You can see it's calling itself forever. We are now at call 3000. Bado inaendelea tu. Still calling. I go fast. It's going to get to a point. It's going to blow the stack because you've called it. It's called itself too many times. Eventually, it will blow the stack. There we go. You can see what's the error? Maximum call stack size exceeded. So what we did, if you use this visualization, that function called itself to eternity. So this call stack, this box just kept going up and up and up and up and up because it never stopped. And the call stack has a limit. It's not an infinite box. So at call 11,217, we blew the stack. Stack overflow. We overflowed the stack basically. Did I answer your question, Mary?
Yes, you did. Thank you.
Okay. Anybody else with a question? So like when you're doing like a recursive solution, you normally have to be very careful. You don't do this. You don't blow the stack. So you need to have like a base case. At what point should it stop? Should it stop executing? Anybody with a question? Something I need to add? Okay. Okay. I think that's clear. All right. So kama kila mtu ameshika, if you don't need me to repeat, we can move on to the execution context. Anybody with a question, or should there's something I need to repeat? You can write it in the chat. Okay. All right. I think that is good. Kama if everybody has understood. All right. So now let's go into the execution context. Okay. So open recent execution context. Okay, so now let's go through this. So we did have an example of this sometime last week. So I will open that page as well. Okay, so we don't need this one. So let me share this link in the chat. So you guys can practice on your own. Okay, so now let's look at another example now using, we want to see the execution context. Trying to remember the name of, what did I write?
It's UI.dev.
Yeah, but what was the last? Let me see if that will work. Yeah, it's the visualizer, but the problem is in Letanga app. I can't remember the exact path. Did I Google that at the time? Can you remember?
JavaScript hyphen visualizer. So UI JavaScript hyphen visualizer.
JavaScript. Yeah, it's this one. Thanks, Mambo. Okay, so we can use this to now see the execution context. So again, this one we can just write some code here. So I think I can copy paste whatever I have. Okay, I don't actually have any code. So function. And then simply return. hi, and then we have let's have a variable with var called first name to Mike. Then I think that's enough. And then let's also have, let's call the function. So now let's go through the code. So I will do this, I will do this, and I will do that. Now let's walk through the code. Okay, so as I mentioned, the global execution context is the first thing that is normally executed. So when you run your JavaScript, that's the first thing that happens. And the execution context, that global execution context, right? It's responsible for a number of things. Okay, so the first thing is, right, it's supposed to initialize this, for example, the window object that you see in your console. It's also supposed to allocate memory to variables at that point. But now let's see what happens. Now we also know about hoisting. And I used to think that hoisting meant that your code, like physically, your variables with var will be put huku juu, like kwa code itself. I thought that's actually what happens. But as we figured out last week, that's not exactly what happens, right? And that's because of the execution context. So when your program runs, we have the global execution context that comes first. So let's go through that process. So the first thing, let's step through the program. Okay, so we see we are now running the global execution context. And the global execution context has two phases: the creation phase and the execution phase. This is supposed to be creation phase. So the creation phase, right, that is when that hoisting behavior happens. Because you can see our first name is already accessible. So what it did, it put this first name variable in memory. Okay, and then it also put the say hi function in memory also, the whole thing. So with variables, it sets the value to undefined. It's there in memory, but it's undefined. And we looked at that because when we tried to console log before we actually gave it a value, it was giving us undefined, not a reference error, not first name has not been, like it's not in the code. It's there, just doesn't have a value. So you can see in the creation phase, we also have what? The window object, which is the global object. Then the next thing we also have is that this keyword is bound to the window object. That is why if you go into my console right now and I say this, it's equal to the window object. That happened during the creation phase of the execution context. So say hi is also available because during that creation phase, right, your functions are put in their entirety in memory. So the say hi will work hata kama uko na, even if you try to call it hapa juu, try to call it here, which we will do, it will still work because it was created during the creation phase. So now we finished creating the execution, the global execution context. Next step, now executing phase now. We now want to execute the code, whatever code we have. So for example, we want to execute first name to be equals to Mike. That's executing the code now. And then we also want to execute say hello, because that's also an execution. We're executing something. So now we are in the execution phase. Then let's move on. Step through, step through, step through. At some point, first name will now be Mike. There we go. We have executed that line, right? So when it gets to this point, because there's nothing to execute here, it skips this whole thing. Kwa sababu hakuna kitu ya ku-execute hapa. So it skips this whole thing and comes here to the first name, then executes it, gives the first name, which was already in memory. Now assigns it a value, sasa, equal to Mike. And then it now executes say hello last. Now, we have two types of execution contexts. We have the global execution context, and we have the function execution context. So when you execute a function, it has its own creation phase and its own execution phase. And you will see that. Now, when we continue to step through it, when you get to say hello, execute it. Did we not execute it? We were supposed to, oh, sorry, say hi, not say hello. Let's restart it and then let's go through it. Raka, execution phase, Mike. There we go. So you can see when we execute, when we get to the function, it creates a new execution context. So this is now a function execution context. And you can see it also has a creation phase. Same things happened. So first of all, the arguments object that comes with your function. It's 0, and then it binds this to window. This is during the creation phase. So if we had any variables hapa ndani within the function, they would now be set to undefined, but not here hapa ndani, hapa within this execution context. So let's continue to step through it. We are now executing, execute, finished, imemaliza. So now let's put another variable here. Okay, so let's step through it. I want you to see that this variable will not be accessible in the creation phase of the global execution context because it's being scoped within the say hi function. So you can see we have first name, we have the function in its entirety, but we don't have last name. It's not here. That's because it's going to be within the creation phase of the function execution context. And when we now call that function, you can see it's right here, ndio hii hapa. So it's also being hoisted, but up to the scope mali iko, it doesn't go beyond that. It's being hoisted bado. That's why we can still see last name before we have a value for it. Because it's being hoisted to the top of its scope, which is this function, and then it's being set to undefined during the creation phase. And then as we step through it, now we are executing. Now it's going to set that value to Jake. Is it making sense? Now, before we go on, now with what I've just explained, I want us to look at something. Let's start the whole thing. Now, Albert is here. Sindio, we were having a discussion like last week when we were doing let and var, and it was confusing us, kabisa. So now, if I take this code and I put it here, do the same thing. Go to here, then I put it in my code. Okay, now what I am going to do is I will open this. I will go into app.js. Then I will take this. Obviously, you don't want to write code this way. It's not ideal, but I just want to show you. Or let's instead say return. It's working, right? Even though we have it before we actually declare the function, including the variable and everything. Now, who can tell me why this is happening? Now, based off of what we've just done, who can tell me why we are not getting an error? Who can try to take a guess? Based off of what we just talked about. Someone wants to say something. Do you think?
Can I?
Go ahead, try.
Okay. I think on the first line, we are calling that function say hi. So as we've seen earlier on this website that you're in currently, the function is hoisted as a whole, like unlike the variable. If we tried console logging the variable hapo pele, we were going to get undefined. But for the function, it is it has its own execution phase. So meaning that the moment we call it, it opens a new execution phase, and that execution phase will hoist or will run the line 4 and line 5 on its own. Once it's done, it can then continue with the rest of the code.
Yes. Okay. Does anybody have another opinion? So it's doing that because it's being put, it's already available to the whole project, to the whole program, even before it gets to this point. Sindio? Now let's try it in the UI. Let's try here. So let's restart the whole thing. And let's step through it. So creation phase, right? Then let's continue. Now we are executing it. Okay, so Albert is right. It's working because, right? Let's do it again. You can see, remember both the phases, the creation and the execution phase. Now, before we even execute the code, before we even do the say hi, because the say hi is executing, right? That's actually executing the function. Before we get to the execution phase, we have the creation phase, right? So it means with functions, they are hoisted in their entirety. So before you even execute the actual function, it's already in memory. So during the creation phase, this say hi is already available even before executing it. So equal, so we can have access to it. So by the time we get to the execution phase, right, it's already in memory. So it doesn't matter where you put it because it was already put in memory in its entirety. It was created at this point in the global execution context, the first phase in the creation phase. So it's there. So to Albert's point, if you try to do the same thing with first name, it doesn't work. It gives us undefined. Because yes, it's hoisting, but we are trying to get that value before we execute that value. We have not gotten to the execution phase, which will now give the first name a value. Hatujafika hapo bado. We're still in the creation phase yani. So basically, the reason unaona first name here is undefined. So when you try to log it here, during the creation phase, before you actually get the value, it gives you undefined. That's why. So Albert was right, but anybody who is struggling with this, is there anything I need to repeat? I hope now this is clear because we were it took us a while before we figured it out. But I hope like now this is making sense. The reason we are getting undefined is because yes, it's hoisting, but it's not initializing the value, sets it to undefined, compared to functions which are hoisted in their entirety during the creation phase. So it doesn't matter whether you call it before your function declaration, it will still work because it's already available to you in memory. Anybody with a with a question? Something we need to redo? Anyone? Okay.
Ian. Okay. How is it different now for the storage between the variable and the function? Since we know that it is stored somewhere, a variable is storing a value. However, it hasn't stored a value yet during that creation phase. So,
yeah.
However, the function also storing a value or storing some data? Well,
in memory.
yeah.
It is. That's how you're able to get like access to everything. So think about like if you've done anything in terms of managing memory, kama ya the low level languages, just going to put a pointer to say hi, including everything. So the last name and everything inside here. It's going to put everything in a specified memory location. So when you're calling it, so when I say hi, it's there already, fully formed. But first name during the creation phase, again, it still allocates memory for it, but hakuna kitu hapo ndani. The value is empty. It's undefined, hakuna kitu, but there is a pointer to that. There's a pointer in memory for first name, but there's nothing inside. But for function, yote iko hapo. Everything is already there for you. Anyone who needs something else to explain? Okay, so what about let and const? Can we try to do those ones in C? Okay, so let's try and see. So let's come here. Let's restart this, and then hapa, let's say want let can 5 is equal to true. See, why are we complaining? We need to change something. Where is that editor? Type ES5. Okay, so it's saying, let's see whether it works, because I think it wants me to tell it to use ES6 instead. Still works. Just a minute, I'm coming back just now. Give me a few minutes. Okay, sorry, I'm back. So let's go through this again. So where were we? Were talking about let and const. So let's do this, because this is not showing me what I want. Step through. Okay, so let is not here. We are not seeing it here in the can drive is not here basically. So what I'm going to do, I will simply come to my code hapa, and I will now have a let, and then set this to can drive, and then set this to true. Then okay, so now let's go into our code. Let's go to the debugger, to sources, can drive set to true. Let's go into this. Let's refresh the page. Okay, so now I will come here. I will come here. Now, I want you to look at something. So when I have my variable as first name, this thing here, it's available in the global scope, right? The global object. So if you look for first name, we should find it somewhere here. First name. Or have we not executed it yet? Should already be here. I cannot find it. Let me just step through the code and see. Okay, that's what I wanted to see, but let me just show you this section here. Let me refresh the page. Now, when you hear people saying that when you use let and const, they are block scoped. That's what people say, right? No, I can't see this value. Here it is. Yeah, the yapa. So first name is undefined, obviously, because of that process of creation phase, execution phase. So currently, they are not available because we are in the creation phase. So hoisting is being done now. You normally hear people saying that when you use let and const, they're not hoisted, but they actually are. So you can see first name is undefined, but if you scroll up, you can see can drive is also undefined. Can drive is this thing here, right? But you can see it's in a different place. Script, iko hapa, so a different place, but it's there. It is there, it is being hoisted. It's just not available to you. In something called a TDZ, a temporal dead zone. So it's not accessible. We can't access it, but it's there. It's undefined. You can see it is being hoisted, but it's not available to us. And then now as you step through the code, it's now true during there, and now it's being executed. So it's being hoisted, it's just not available to you, just don't have it. You can't access it. It's being put in that place called a temporal dead zone. And I'll also send a link to that temporal dead zone JavaScript. There is a very nice code camp talking about it. You guys can have a look at that. So I hope like this has cleared up a lot of stuff, what we've done today. Anybody with a question or a comment about the global execution context or hoisting? Anything I need to clear up? Any comments? Albert, did you know that it normally also hoists let and const?
Yeah, I did. No, but const is it hoisted?
Yeah,
I think let is only
both.
hoisted.
Does it for both?
Wait. Now, can you now call an arrow function from the top that is defined down, maybe at a later line?
Okay, so we try that. So we try to use an arrow function.
Try you to use an arrow function because that is a constant variable, I believe.
Okay. Let's see. Const. got to remove these things here. So we try to call it hukuju, sindio? Okay, let's see. It's already complaining. Access to call arrow before initialization. So const doesn't work. But is that only for arrow functions?
Try a variable and let's see a constant variable. Okay,
Yeah.
I think.
Let's see.
But that is already a constant variable, so
yeah, unless it's behaving differently because it's an arrow function. Because let's try a variable. Let's remove this, and then let's check our sources. And let's scroll down. And let's see whether it's going to be set at this point by this point. And then let's. Oh, it is. It's actually hoisted. Sindio hii hapa.
and defined to bado.
Yeah,
That
it's
is why
here.
I can't actually execute it.
Yeah, because they are also being put in the temporal dead zone. So
Yeah.
you see whether you use let or const, they're still being hoisted. Yes, they're just not available to you. But Zico, they are all undefined during the creation phase. Yeah, so both const and let are hoisted, but within the temporal dead zone. You just can't access them. They're not in the global or anywhere. But so you can see we have another script here. They're in the script scope, not in the global scope. Right. Anybody with a question? Any questions? Joseph, do you have anything to add?
Yeah, no.
Okay. All right. So I think now we have like a good understanding of what actually happens internally with under the hood and in JavaScript. Some of those things are very confusing, but I think now it makes a bit more sense. I think now if you go through the material again, you should be able to understand exactly what is going on. The call stack, hoisting, and so forth and so forth. So what we'll look at tomorrow is sorry, we're done with this. Did I not open it up here? What's going on with my program? I think I shared the link to the other tool here, Cindy. This one. But you joined late, so I don't think you got the link to it, which is Albert and Joseph. Actually, I don't think you got this when we were talking about the call stack. Did you ulipata kama tunaongea kuhusu call stack kweli? Albert.
Yeah, I got you discuss about the call stack.
Okay, you got the link as well.
Yeah, JavaScript 9000 or JavaScript something. I already have it somewhere.
Okay. Does anyone not have the link to this? I resend it.
I don't have.
Okay, let me send it to the chat and you can have a look at it.
Ian. So what is that one use case that you'd maybe go back to using var instead of either let and const?
I have never seen, I've not come across a situation where I've had to use var instead of let, because it was just problematic for a very long time.
Okay.
So even the introduction was because it was really needed. So kutoka ile siku wali introduce var, very few people actually find a reason to use var as opposed to let. So I've never encountered a situation where I'm using var instead of let. But just like to explain to you guys, like, what is the main difference? But I've never come across anything. Maybe Joseph, have you come across a situation where you needed to use var instead of let?
No, but for me, the alternative, like, you know, if you write TypeScript, you can compile it to whichever version of JavaScript you want.
Yeah.
So if you're doing TypeScript, you can just say like ES 2013 or something, and it'll become var and everything. Yeah. So if I like want to support like some pretty old browsers, that's what I like to do. Just write it in TypeScript and then convert it to the whatever you want, like whichever ES version.
Yeah. So unless you're targeting like a very old environment that needs var and does not support let, I don't see any other reason why you would need to use var. Okay. So we'll talk tomorrow. We'll talk about the event loop, because now this task queue and the micro task, right? This is now stuff to do with how the event loop works, how it's able to, for example, if you have a set timeout set to 0 milliseconds, and then you have a console log chini yake that is just using the normal synchronous call stack, right? The thing without the set timeout will execute fast, hata kama uli call after, and that's because of the event loop, the task queue, and the micro task queue. So there's a way they all work together. I mean, it's a very important to understand, especially the event loop if you're working with Node.js, because that's the whole thing with Node.js. It relies heavily on the event loop. So the way to identify whether something is using is an API that is using the event loop or the task queue or the micro task. Anytime you see the callback pattern anywhere, you're writing a function that is using a callback, you're using the task queue, you're utilizing the event loop, and you're utilizing the micro task. But there's a difference. Kuna difference between using promises and using a callback in terms of the task queue and the micro task queue. Because promises use micro task and callbacks use task queue. So micro tasks have more priority than task queue. So there's a difference in how they put in the functions back to the call stack, because everything has to go back to the call stack eventually. Because remember, you're using one pipeline. So they still have to go into the call stack, get executed, but they don't do it until, so if you're using a callback, it will not be put onto the call stack until the call stack is empty. So we'll look at those examples tomorrow, as well as just have like a visual view of what it's actually doing. So I guess we can end there. We will resume tomorrow now. We'll finish up the event loop. Then we'll do a recap on it. We'll talk about what the event loop does, how it works. We look at examples back in Node.js. We'll do an example in Node.js, then see how it works. And then once we are done, now on Wednesday, we'll do a brief recap. And then after we do the recap, we'll now start with regular expressions. Another topic that is just can get complicated very, very fast. But we'll try to approach it pole and see whether we can get a grasp on it. So, all right, so I hope you guys enjoyed today's session, even though we didn't write so much code. I think we went into some of the integrities of the language. So even when you're debugging, this knowledge now comes in play when you're debugging something. Makes sense when you're getting, it's like unwanted behavior. Most of the time it's because you're not understanding the internals of the language. So hopefully this will give you like a platform to do that. So I hope you enjoyed the session, and I will see you guys tomorrow. Thanks for joining. Have a lovely evening. Bye.
You too.
Okay, bye.
Bye.